Thank you. So Steven said I work on the Cloud Foundry team at Pivotal. This is just a real quick little bit about what I do. My role is sort of like a developer advocate role, but also have one foot in the engineering side, so it's sort of half engineering, half developer advocate, and that's kind of what my role is. I've been sitting in this room for a few of the sessions, hearing about CloudBees, hearing about Google, and I just think it's a really exciting time to be part of this PaaS world. There's a lot going on in the platform as a service world, and a lot of it's very exciting, and so we're going to talk a little bit about that today. This talk is going to be kind of a combination of some general PaaS concepts and then some very specific things about Cloud Foundry and New Relic. My boss, who's the product manager of Cloud Foundry, just published a blog post today. It's on the Cloud Foundry blog, blog.cloudfoundry.com. That talks about what are the essential elements of a platform as a service. And that's a really good blog post, and it makes a lot of really good points. It's way more than we could fit in 35 minutes, so I'm just going to hit on a few of those that kind of tie into the Cloud Foundry and New Relic relationship. So starting off, what should platform as a service mean? On the Cloud Foundry team, what we think platform as a service should mean is moving up the stack from talking about having virtual machines that we deploy a software stack on top of to just pushing applications. That's essentially what a platform as a service should be. You push your application, the platform does everything that needs to get the application to run, and that's all you have to worry about. So it should be a layer above the infrastructure as a service or a layer above the virtual machines, and it should automate all of that preparing of what it takes to run an application. And I thought Sasha from CloudBees hit on this stuff really well. Another one of the essential elements of PaaS that James Waters talked about was services abstraction. So you should have a platform that can expose services that your application can detect and then use, and have the platform play into that part of it as well. So let's take a few minutes and talk about what this means to move up the stack from infrastructure as a service to platform as a service. So in a lot of IT worlds today, what it means to run an application is you get a virtual machine handed to you by the IT team. Maybe that was built in an automated way with infrastructure as a service. Maybe it was built manually, but what you get is a virtual machine. And you get that virtual machine as an application developer, and you build the software stack on top of there. So you might need to put a JVM to run a Java app, or a Ruby runtime to run a Ruby app, or a Node.js runtime to run a JavaScript app. So you put that runtime in place, and then you might need to also put an application server in place, and then you can put your application on top of that. And as well as putting the software in place, you have to configure it. So if you're pushing a Java web application, you may have to install Tomcat and then configure Tomcat the way you want it. And then you have to maintain all of that stack going forward. So what app-centric deployment means is you're not worrying about that software stack anymore. You're just pushing your application, and the platform is taking care of the runtime, the app server, anything else that's needed to run your application. That's the platform's job, not your job. Of course, one of the big benefits of this is it simplifies your life as an application developer, because all you're worrying about is your application, and the platform is taking care of all the other details. One other really important benefit of this is, especially for big enterprises, you get consistency of that platform. So you know that every time somebody pushes a Java app, they're all using the same Java virtual machine, they're all using the same Tomcat version, they're all configured the same way. So that consistency helps you with some of that configuration drift that you can get. If everybody's managing their own virtual machines and installing their own software, they're all configuring it different ways, they may be tweaking different versions, and that can be hard to maintain from an IT perspective. So platform as a service, along with making it easier, also makes things more consistent and makes it a lot easier to manage that whole infrastructure. It also has a big impact on scaling, because if you're just worrying about pushing your application and the container is taking care of everything else, then if you want to scale up your application, you aren't necessarily creating new virtual machines and then scaling those virtual machines up. You're just doing containers within a virtual machine. So let's talk about what it means to abstract services on a platform as a service. Most applications need some kind of a service to run, a database, message queues, email services, web services, all of those sorts of things. And you want your platform as a service to also give you some level of abstraction over that. With Cloud Foundry, we have a concept of service brokers, which allows the provisioning of services to be automated. So as an application developer, you can say, my application needs a database and a queuing service, and you just describe what you need, and the platform can automatically provision the database, provision the queuing service for you, and expose those credentials to your application that are needed for you to actually use that. That works really well in a lot of cases. In some cases, you may have some big heavyweight proprietary database that either technically or politically, for reasons either technical or political, you can't automatically create new instances of those databases. You need some DBA group to do that for you. If you have a big heavyweight messaging system, it might be the same way. You might also have web services that your company subscribes to that you pay for. So those services aren't really configured. Your app just consumes them, and you just need a URL and the credentials to get to it. So in those cases where you can't automate the provisioning of those services, you just need a way for you to tell the platform, here's the services that are available, here's the credentials, here's how I get to them. But one way or the other, whether those services are automatically provisioned for you or whether they're provisioned externally and you're just telling the platform about them, either way the platform can advertise what those services are that are available to your application. And the application, instead of hard coding credentials into your application and connection info, your application can query the platform and say, tell me what services are available to me, tell me the URLs I use to get to them, and any credentials I need to authenticate to them. And it's also important that these service instances can be environment specific. So you probably have development, QA, staging, production, whatever range of environments you have that you promote your application through. You need those instances to be able to run in each of those types of environments. And you don't want to have to change your application source code or even recompile your app to move it from one environment to the other. So that's the other place the platform can play into that in giving you that abstraction. So you just push your application and you say you need the database, and it gives you a dev database in the dev environment all the way up to a prod database in a production environment. So now we'll get a little bit more specifically into Cloud Foundry and New Relic and what this means in those environments. So with Cloud Foundry, you get this command line tool called CF, and that's the way that you manipulate the Cloud Foundry environment. One of the things you can do with that CF Cloud Foundry tool is to say, I want to create a new service instance. So you can say CF create service, a MySQL database, a Postgres database, a RabbitMQ instance, a SendGrid email service. And one of the things you can say is, I want to create a New Relic service. What that means is it's going to create a new account for you in New Relic. Cloud Foundry uses AppDirect as an intermediary. So New Relic has integrated with AppDirect, and we've integrated with AppDirect. And that helps us do all this automatic provisioning of New Relic accounts. So with this one command line, that's all you need to do to be able to create a New Relic account that your application can know about on Cloud Foundry. And it does this within the environment you're running in. So you can do this in dev, staging, and prod, and you get a unique New Relic account for each one of those for your applications. So then your application needs to be able to use this New Relic service. And the way to do that in Cloud Foundry is to do this bind service call. And all that does is expose the credentials from that service to your application. So this combination of CF create service and CF bind service fully automates the creating of New Relic accounts and exposing everything that your app needs to use that New Relic account. And this is just a different view of that. The other way that you can create a New Relic service is to go through a console on Cloud Foundry. And there's a marketplace where you can pick from all the various services that Cloud Foundry has exposed. New Relic being one of those. So if you click this buy this plan button, that's automatically creating an account for you on New Relic and tying that New Relic account to your Cloud Foundry account. Right now we just have one free plan. That's because Cloud Foundry hasn't started billing customers for use on our Pivotal hosted version of Cloud Foundry. So we're not going to charge you to use anybody else's services. So right now it's everything free end to end. Very soon Cloud Foundry will add paid tiers to our service. And at that time we'll start adding paid tiers to these services as well, like New Relic. So what do you need from an application perspective if you want New Relic instrumentation in your application? There are two main things that you need. One is you need to include a New Relic agent in your application. And the other thing is you need to configure that New Relic agent. And the two main pieces of data the New Relic agent needs is a license key and the name of your application so that it can give you a nice dashboard that lists all of the applications that you're having New Relic monitor. So let's see what that looks like for a Ruby application. Ruby actually makes this really easy. To add monitoring to a Ruby application, You just include the New Relic gem in your gem file, and then when you push the application up to Cloud Foundry will bundle the application and pull down that gem, and New Relic monitoring just works with Ruby that way. So for the configuration piece, this is where some Cloud Foundry specific stuff comes into play. We will give you a pre-configured New Relic configuration file, and those two pieces of data that you need, which are the license key and the application name, we will pull from the Cloud Foundry environment. The New Relic agent for Ruby supports ERB syntax in their configuration file. So we can just look at this ERB syntax a little bit here. When you bind a service to an application in Cloud Foundry, it gives you the connection info and the credentials you need to talk to that service in this environment variable called vcap services. So this is just parsing that vcap services environment variable, which is in a JSON format, finding the instance of the New Relic service, getting the credentials out of it, and then getting the license key out of that credential. So you can include this one New Relic YAML file in your application, and when you push that application to development or staging or prod, it's going to pull the right license key that you've provisioned for that environment into your application. So you don't have to change that license key as you move it between your environments. And it does the same thing for the application name. It pulls that application name out of the Cloud Foundry configuration. So back to the earlier slide talking about service abstraction and how that service abstraction should help your app connect to all of its services, including moving through the environments. This is one way that we can do this using the New Relic service and Ruby on Cloud Foundry. Okay, any questions so far? Let's talk about Java. Java actually makes things harder, and this isn't a New Relic issue that's making it harder. It's a Java thing that's making it harder. All monitoring systems on Java basically work the same way. You have to install the monitoring agent at the JVM level, not at the application level. That way the monitoring agent can track threads and memory and heap and all those other things that you want to see in your application. So the way that you install New Relic into a Java application is with this java-agent command line. And that brings up the question. Remember on the slide earlier we talked about the platform puts that complete stack in place and figures out how to run your application. But if the platform is doing that, how do you then inject this New Relic monitoring into your application when it starts up? So the way that we've addressed this on Cloud Foundry is using this concept of Buildpacks. If you're familiar with Heroku, Cloud Foundry got this Buildpack design from Heroku. The design is exactly the same between Heroku and Cloud Foundry. So in theory, Buildpacks that run on Heroku will also run on Cloud Foundry. You can certainly write Buildpacks that will only work on one or the other, but in most cases, a Buildpack built for one will work on the other. So we talked about the fact that the platform should put all of the software stack in place for you. To get one level deeper in detail on that, the Cloud Foundry system doesn't actually know what type of application you're trying to run. The Cloud Foundry doesn't know whether it's a Java app or a Ruby app or a Node app or anything else you may want to run. When it comes time to prepare a software stack for the application, Cloud Foundry delegates to a set of build packs or a build pack that you name, and then that build pack is the piece of code that does all that work of putting the stack in place. So that makes that whole process of building the software stack as modular as it could possibly be. So you can pick whatever build pack you want out there in open source and say, here's the build pack I want to use to push my app. And Cloud Foundry just delegates all that work of building the stack to the build pack. So the build pack will put down the runtime, meaning the JVM or the Ruby runtime or the Node.js version you want. It will put the app server in place, and it can also add any other libraries you need to your application. So that's kind of a really quick overview of build packs, and then we'll talk about how this plays into New Relic. So this combination of build packs to build a software stack and the services abstraction allows build packs, when it's staging an application or putting a software stack for an application, can also inspect the list of services that are bound to that application and make decisions based on that. So the build pack can make decisions based on two things: the bits that it sees in your application and the services that it sees are bound to your application. So the Java build pack that we run on Cloud Foundry has intelligence to look to see if there is a New Relic service bound to that application. If there's New Relic service bound to your application, then it's not only going to put down the JVM and Tomcat, but it's also going to install the New Relic agent for you and configure it and just make everything work. So we call this zero-touch service integration, meaning you don't have to do anything to your app. You don't have to add the New Relic Java agent to your Maven build file, your Gradle build file. You don't have to add a New Relic configuration file to your application. You can run it locally in Tomcat and then just push it to Cloud Foundry without changing a thing, and it all just works. So we'll go into some more detail about exactly what that looks like. So when you push your application to Cloud Foundry, this whole staging process happens with the Buildpack. And the Buildpack is responsible for laying down into a file system everything that your application needs to run. So this is just an example. After you've pushed an application, you can use this CF command called files and actually inspect the file system that was created for your application. So this is just a listing that would come out of that CF files command for a Java web application that you've pushed to Cloud Foundry with New Relic. So if we look at the bottom here, the metinf, webinf, and assets folders, those are your application bits. Cloud Foundry doesn't touch those at all. It just dumps them in the file system and then turns everything over to the Buildpack. And then the files on the top are the files that the Buildpack puts in place. So we can see in this .java directory, that's where the Buildpack put the Java runtime environment. Cloud Foundry doesn't care where it put it. That's just the convention that the Buildpack uses with this .java directory. And we can see about in the middle, there's a .tomcat directory. That's where the Buildpack downloaded the Tomcat distribution and unzipped it in a standard configuration. And then in the middle, there's this New Relic stuff. So we can see that the Buildpack created this New Relic directory. The Buildpack downloaded the New Relic agent jar file, dropped it into this file system, downloaded a basic New Relic configuration file, dropped it in the file system also, and then created this logs directory. So your application didn't have to worry about any of that New Relic agent jar files. It's all put in place by the Buildpack. And then the next thing we can look at is the startup command that is created by the Buildpack. So the Buildpack is responsible for putting the files in place and then for creating a command to launch your application. And normally for a Java application, the start command would be, in this case, it's a Tomcat application. So the very last line of this, it's running Tomcat start script. It's setting some memory options. It's setting some other Java options. And then there's all this stuff in the middle that the Buildpack put in there because it detected that it was bound to a New Relic service. So we have the Java agent pointing to the New Relic jar file. We've given a name to the application that's the same name you gave to it in Cloud Foundry. So when you're running the app in Cloud Foundry and you're looking at your dashboard on New Relic, the names are the same. And we've given your license key for New Relic and then just a place for the log files. So this combination of the previous slide where it put all these files onto the file system and this slide where it creates a startup command, that's what enables this zero-touch capability of you just push your Java app to Cloud Foundry and the Cloud Foundry platform does everything else to not only run your app, but get the monitoring started on on New Relic. And this is my last slide, so this talk went really, really fast, so I hope you guys have lots of questions. So here's some reference information for you. This top link is a link to a video on YouTube where we do a screencast of this whole process, build an app, push it to Cloud Foundry, including a New Relic service, and then go to the New Relic dashboard and start watching the metrics flow. So that's like a 6-minute video that basically goes through that whole process and shows you all the details. If you want to try this yourself on Cloud Foundry, you can go to this Cloud Foundry Getting Started link there. And that's a documentation page that tells you everything you know to get started on our Pivotal hosted Cloud Foundry, how to create an account, how to get the CF command line tool, how to get everything going. And there's a registration page you go to. On that registration page, there's a button that says invite code. If you put this word FutureStack all lowercase in that invite code, you'll immediately get an account on Pivotal's hosted Cloud Foundry, so you can try this yourself. And then that final link is just a link to our documentations page that talks about how to set up New Relic in a application on Cloud Foundry. And I just saw today New Relic released their Node.js capability, so now a task on my plate is to go demo how to do Node.js on Cloud Foundry with New Relic. That should be pretty neat. Okay, any questions? Yes?
If you want to use your existing New Relic key, not a generated key, can you still use Cloud Foundry to automatically position New Relic, or do you have to kind of now roll it yourself?
That's a very good question. So back to this slide again. Just going to back up since we got lots of time. So two types of services you can use here. One is automatically provisioned service, and the other one is you telling the platform about a service you want to use. We call those user provision services. So you can do New Relic either way. You can do this command where you say cf create service New Relic, and we'll create an account on New Relic for you. Or you can just tell Cloud Foundry, I have a New Relic account, here's my license key, and I just want you to use this. And no, you don't. Either way, whichever way, Cloud Foundry will detect that you have a New Relic service bound to your application. And in full disclosure, there was a bug in the user-provided part of this in the Java Buildpack that just got fixed, so that'll be rolled out to Cloud Foundry soon. So if you specify the Java Buildpack via a Git URL, that'll work today with either a Cloud Foundry provisioned or a user-provided New Relic service. And within a week or so, then it'll be automatic on the platform as well. So either way works. Anything else?
So looking on the website, I see you planning to support Python, or you already have support for Python?
With the Buildpack capability, so here's what that looks like in Cloud Foundry. Cloud Foundry supports Ruby, Node, and Java out of the box. So if you just push your app to Cloud Foundry without specifying any more information, it needs to be a Ruby, Java, or Node application. If you want to push a Python app, then you just give one extra parameter on that push command, which is a get URL to the Python Buildpack. And there's, last count, I think 3 different Python Buildpacks that are out there that are known to work on Cloud Foundry. So that Python Buildpack won't have this special New Relic service binding knowledge because those Buildpacks are mostly both Heroku and Cloud Foundry capable. You could fork that Buildpack and customize it to do other things if you wanted to, but yeah, Python is definitely something that people are doing on Cloud Foundry today. Yeah.
So you have like support for Ruby or whatever, but don't you also need to have intelligence in there to support like the actual frameworks, like say Tomcat or Rails?
Yes. Yeah. So the Ruby Buildpack knows about Rails Rack and Sinatra. The Java Buildpack knows about basic Java apps that you just run with java-jar. It also knows how to identify a servlet application, in which case you get Tomcat. It knows about Groovy applications, Play applications, and I think that's it right now. So yeah, those Buildpacks know, they typically know not just what language the app is written in, but what framework it's using. So in the case of Java, Spring, Play, Groovy, Grails, it knows each of those and knows how to set up the application right. So I showed the start command for a Tomcat application. The start command for a Play application would be completely different. The Buildpack would detect that and set it up completely differently. Anything else? Since we've got lots of time left, if anybody just wants to see this live in action, I'll be up here and we can push apps to Cloud Foundry and watch it work and do anything else like that we want to do. All right. Thank you.